All right, as promised, here's the second part of today's lesson. So for the second part, we are really going to be focusing on area. So you're going to be able to find the area of a composite figure. So like we said earlier, if we want to find the perimeter, that's going to be the fence line per se, or the outside of a figure, right? Well, now we want to find the area, and that's going to be the total space. That's going to be the total space within the figure. All right, so it'd be all of your area. All right, you also notice that all of our answers with area should be squared. All right, so when we do area with a composite figure, it gets a little bit tricky. All right, so for starters, what we're going to want to do is, I don't know how to find the area. I don't have a formula for this. Remember, the formula sheet's in Schoology, but I don't have a formula for this shape. I don't know what to do. So I need to turn this shape into more manageable shapes. Oh, so now I have a triangle at least. Well, looks like I have maybe a square, possibly a rectangle. Looks like it'll be a square. And I could do this one just to keep with only having to use two formulas. And it looks like I have another possible square, maybe a rectangle. Nope, definitely a square. And another triangle. From here, I could actually sit down and figure out the area of this shape. Of course, I would have to do a little bit of work. Like I'd have to figure out, you know, the length of this side because I don't know it. This side's good, this side's good. And I would want to figure out the length of this side because I don't know it. But we can figure those out the same way that we kind of figured out the lengths of sides we didn't know doing the perimeter. All right, so what I want to do here is I want to turn this into manageable shapes. And I want to do so with the least amount of effort too. Like I don't want to have to find a bunch of sides. I just want to have to find as little amount of sides as possible. So I'm going to cut it off right there. So now I have two rectangles. All right. And I'm going to number these rectangles, rectangle 1 and rectangle 2. Well, for rectangle 2, I have my length and my width, which is going to be the formula, which we'll talk about here in a little while. But for rectangle 1, I only have my length. I don't know what my width is, right? I don't know what this value is. But I have this 10 here and this 6 here, which are both horizontal lines. And I know that if I could grab this arrow line and bring it down, it would overlap this 10. So we're going to use our same concept as we did before. I'm going to take 10 minus 6, and that's going to give me 4. So this line is technically 4 centimeters. All right, from here, all I have to do is use my formulas. Now remember, guys, you want to make sure you have that formula sheet. So my area of my first rectangle is going to be length times width. And in this case, it's going to be 9 times 4. And I'm going to go ahead and add that to the area of my second rectangle. Whoops. Area of my second rectangle, which is going to be length times width. And that's going to be 6 times 2. Now remember to follow your order of operations. We're going to multiply first. So we'll have 36 plus 12. And that simply is going to equal 48 centimeters. And these all should be squared. All of these should be squared. I apologize for the typo. All right, so our answer is going to be C. All right, so we got 4 problems coming up. To be honest with you, I think these are the hardest problems that you're going to have all year. Okay, so let's just get through it and we'll be all right. Well, they already kind of give us a clue here, so we know that we're going to have a triangle, so that's going to be my first shape. I notice that I have a side length, a side value here for the top and bottom, so I'm going to go ahead and cut this off and make this my second shape, and then this will be my third shape. All right, so I'm going to look for the area of my triangle, and that's going to be plus the area of my rectangle, and that's also going to be plus the area of my rectangle. Well, let's see. So it looks like I'm good here. I'm good here for my second figure. My third figure looks pretty good on this side, but I don't know what this top line or bottom line is. But again, I can use the same trick. So I have this 6 here and this 20 here. So 20 minus 6 is going to be 14. So I know that this line is going to be 14 centimeters. So that's good. For my triangle, I have a height, and now I know my base is going to be 14 centimeters, right? Because it's the same as the bottom. So pretty much I have all of my info. Well, if the area of a triangle is 1/2 base times height, so that's going to be 1/2 times 14 times 3. And we're going to add our area of a rectangle, which is going to be length times width, and we have them circled, so that's going to be 6 times 8. And then we are going to add the area again. It's going to be length times width, and that's going to be 15 times 14. Now, if you look at this, really looks like a square, but you have to be careful, you know, because these things might not be drawn to scale. So you have to make sure that you're actually looking at the numbers and not assuming things based on the shape. So let's see, 1/2 of 14, 7 times 3 is 21. 21, 6 times 8 is 48. And 15 times 14 is 210. And that's going to equal 279 centimeters squared. And our answer is B. Right, you'll notice that all of our areas are squared. All right, this guy. This is an ugly problem. It's got ugly numbers, but it pretty much gives you all of your information. All right, first thing I want to talk about before we even read the problem is what a diameter is and what a radius is, right? A radius. So the diameter was that whole red line that goes all the way through the circle, touches touches both sides of the circle and goes through the middle. Well, the radius just starts in the middle and touches anywhere outside of the circle. So we know that this radius is going to be half of this line. And we know that this side is 0.4, so that means my radius is 0.2 centimeters. Right away, I have all of my information that I need to do this problem. So let me go ahead and label. I'm going to have this as my first shape. This is my second shape. Let's look at the problem. A rectangle is shown has a length of 0.7 centimeters and a width of 0.4 centimeters, as seen in the picture. A circle is drawn inside that touches the rectangle at 2 points, which is the closest total area of the shaded region of the rectangle. So we don't want any of this white part in. We're just looking at the shaded gray part. So it's kind of like we're cutting a hole in a piece of paper, and then we just want to figure out what area we have left. Well, we have the area of a rectangle, and that's going to be plus the area of a circle. So for the area of a rectangle, we already know right away it's going to be length times width, and here they give us those, 0.7 times 0.4. All right, the area of a circle, you guys are going to want to make sure you look at your formula sheet, is going to be pi r squared. Well, we already determined that our radius is 0.2. Well, we know that pi is 3.14 in 8th grade. And we just need to multiply that by 0.2 squared. Do not forget this square. All right, when you do this, hold on. I did this in class too. Goodness. Where's my eraser? Here we go. All right, so far we've been adding everything. Can't believe I did it again. We've been adding everything. Well, look, I'm cutting this hole out of my piece of paper. So I'm subtracting my circle. I'm subtracting the circle. I apologize for my mistake, but I am subtracting the circle. All right, so when we go ahead and solve for this, we get 0.7 times 0.4, which will be 0.28. And then we have 0.2 times 0.2 times 3.14, which is going to be 0.1256. And when we subtract these numbers, we end up with 0.1544, and that's going to be centimeters squared. All right, again, apologize for this typo. It's all over this lesson, but these all should be squared. So we have 0.15. Well, if we're rounding to the 100th, you can see that it's just going to be D. All right, another circle problem, another subtraction problem. So find the approximate area of the shaded region. So again, this is like we have a piece of paper and we're cutting out a half circle. So my first shape is my rectangle. Second shape is my circle. This one's super awesome because they give us all the info we need. We don't have to do anything but plug and chug with formulas. So area of a rectangle plus area of a half circle. And I like to kind of put this half right here. It just makes it so that way we don't forget. So we know that area of a rectangle is length times width. And we know that our length is 30 centimeters and 15. So we'll have 30 times 15. And we know that the area of our circle is going to be pi r squared. But we only need the area of a half circle. And from here, we just have to plug in. And we have pi, which is 3.14. And then our r, well, if this is a half circle, then our radius is just going to be the same as our base number, which is 15. All right, and then from here, you just have to plug and chug. Put them in your calculator. So 30 times 15. I did it again, didn't I? I did it again. If any of you caught this again, remember, we are looking for just the shaded region. Maybe I'm doing this on purpose, so that way you guys are like, oh, there he goes, making a mistake again. I'm not, it's just a mistake. But we're only looking for the shaded region. So we're cutting out all of this white half circle. So we just want this shaded part. So we are subtracting. Subtracting. Do not do like me and make that mistake. You will get the wrong answer. All right, and then we also have to remember to square our radius. Always have to square the radius when we're doing an area of a circle. And that's going to be 226.57. Is that right? 15 squared times 2.14 times 0.5. No, that's not right. It's going to be 353.25. And when you solve for this, you end up with 96.75. And I apologize again, this should be 9.75. So our answer should be B. All right, last but not least is this ugly arrow question. This is probably my least favorite, but it's not hard. So first thing we're going to do is we're just going to cut this off. So now we have a rectangle and a triangle. And let me move this 2 a little bit. Move the triangle. Well, I need to figure out what the height technically is of this triangle. This triangle is kind of tilted 90 degrees. So if we like tilted it back up, this would be the height. Look, you have this 26 and this 20 here. So 26 minus 20 is just going to give you 6. So your height is 6 inches. All right, so now you're down to 2 pieces. So we have the area of a rectangle plus the area of a triangle. And we're adding them this time because it's all together. So we know that the length times the width of the rectangle, which is going to be 9 times 20. And we're going to add that to our area of a rectangle, which we know is 1/2 the base, which we're going to say is 13, times its height, which is 6. And when you simplify this, you get 180 plus 39, I believe. And that's just going to be 219 inches squared. So the answer is, in fact, C. All right, good luck on your test. Make sure you guys study. It's going to be a tough test, but you guys should be fine. If you have any questions, make sure you ask. Other than that, have a good one. Thanks for watching.